subtracted fractions. Now we, of course, are going to subtract mixed numbers. Let's look at this first example. 3 and 2/3 minus 2 and 1/3. I've illustrated this for you on a number line. So my number line goes from 0 all the way up to actually 4 here, right? 12/3 is 4. And you can see in between it's got 1 and 2 and 3, all shown in thirds. Okay, so this time we're starting at 3 and 2/3, but we know that 3 is the same as 9/3, right? Plus 2 more thirds. So 3 and 2/3 is the same as 11/3. 9 divided by 3 was 3, so that's why we converted that. Or you could also think about just multiplying the denominator by the whole number to give you that numerator there. Okay, so we started at 11/3 right here, and then subtracted first 1/3, and then subtracted 2 wholes. But remember, 1 whole is 3/3. Another whole is 3 more thirds, and that brought us all the way down to 4/3, also known as 1 and 1/3, right? So they've written the answer here, 4/3 equals 1 and 1/3. Of course, I'm going to show you my shortcut way, because now that we understand the visual model, I like to show you a shortcut. Now, similar to when we added, we're going to deal with the whole number and the fraction. But when you subtract, it's really important that you, if you're subtracting a mixed number, you subtract the fraction first. And that's actually fun to say, fraction first. Say it 5 times fast. Fraction first, fraction first, fraction first, fraction first, fraction first. Whew, that's hard to do. So, in subtraction, that's really important, and you'll see why as we go through this video. But this time I'm going to do 2/3 minus 1/3, and that leaves me with 1/3, right? And then I can deal with my wholes. 3 minus 2 leaves me with 1. And we agree. That's the answer that we were hoping to get. Now, the reason that's so important to do the fractions first is because otherwise you might end up with the wrong answer. Let me show you a wrong way on here. So this is going to be wrong. Do not copy this down. I just am showing you a bad example so that you can avoid it in the future. If I looked at this and I said, oh, well, I know 5 minus 2 is just 3, and then I had a third, so I'll put a third on there. 5 minus 2 and 1/3 is 3 and 1/3. And it does not equal that. And that wouldn't even really make sense, right? Because if we took away 2, we're already down to 3, and then you took away a third more, so then you're down to 2/3. So this is wrong, right? We can't do it that way, because what I've done here is I did 5 minus 2, but then I actually added on a third. So you want to be really careful with that. Let me erase this bad example and show you the way I like to do it. So if you have a good enough sense of fractions, you could do it in your head just like I was just describing, how we got down to 3 and then took away 1 more third and then still had 2 and 2/3 left. But that takes a pretty advanced sense of fractions. So here's the foolproof way that always helps me. So I'm going to pretend that there's an invisible 0/3 here, right? This is because it's just 5 whole, it's like 5 and 0/3. So if I try to do 0/3 minus 1/3, I can't do it, right? I get a negative number. So that tells me I need to decompose, or what I like to call borrow, before I'm ready to subtract. So instead of calling this a 5, I'm going to call it a 4 and 3/3. Do you agree that that's the same thing, right? 5 is the same as 4 and 3 more thirds. 4 and a whole equals 5. And then I also have 2 and 1/3 still. Keep that. Okay, now when I do fractions first, now I'm in business. 3/3 minus 1/3, I can do that. That's just 2/3, and then I'll do my wholes. 4 minus 2 is just 2. So we get 2 and 2/3 with the help from the borrowing. Again, you see why we really got to do those fractions first if we're using this method, my shortcut way. Let's try another one. Read this equation with me. 6 and 1/6 minus 1 and 5/6. We always say fractions first. 1/6 minus 5/6. Could I do it? No, I'd end up with a negative number, right? So that tells me I need to borrow. I'm going to borrow 6/6 for a whole. But I already had 1/6, so now I had 6/6 plus one more 6, it's like I have 7/6. Right? Do you agree that 6 and 1/6 is the same as 5 and 7/6? We just converted that. And now we'll do minus 1 and 5/6, and now I'm in business. Fractions first. 7/6 minus 5/6 is 2/6, and then 5 minus 1 is 4. Great. Let's try a few more. Some of them are going to have borrowing and some of them won't. Right? To keep you on your toes. You switch colors here. Okay. So fractions first, or actually let me read the whole equation. Read it with me, or expression I should say, because it doesn't have an equal sign yet. 3 and 4/5 minus 2 and 1/5. Fractions first. 4/5 minus 1/5, can I do it? Yeah, that's just 3/5. And then 3 minus 2 is 1. So I got 1 and 3/5. Okay, that one wasn't so bad. Yeah, let's do this one together, and then I'll have you try a couple on your own. So remember, this has a 0 here, 0/4. So if I say fractions first, and I say 0/4 minus 3/4, could I do it? So I'm going to borrow. Instead of 7, I'll consider it a 6 and 4/4 minus 4 and 3/4. Now I'm in business. Fractions first. 4/4 minus 3/4 is simply 1/4, and 6 minus 4 is 2. 2 and 1/4. Okay, we got a couple more, and I think I made both of these borrowing to stretch your brain and have you practice that. So go ahead and pause the video and try these on your own. Play back when you're ready to see the answer. Read it with me, this one, number 3. 3 and 1/5 minus 2 and 2/5. Fractions first. 1/5 minus 2/5. Can't do it, so I need to borrow. I'll make this a 2 and 6/5. Those are the same. So I didn't change, even though I changed the way it looked, I didn't actually change the problem. Now fractions first. 6/5 minus 2/5. 4/5, and 2 minus 2 is nothing. So that's just a difference of 4/5, which makes sense too, actually. You might have realized that one counting up, right? If I was already at 2 and 2/5, well, then it would take me 3 more fifths to get to 3, and 1 extra fifth after that to get to 3 and 1/5. So it took me 4/5 total to use the counting up strategy. That's a perfectly appropriate strategy as well, but again, that one does require you to have a really good sense of fractions. So just as we're still in the early stages of learning about fractions and mixed numbers, I think it's easier to have a shortcut method that you can always count on, which is why I'm showing you this fractions first and borrowing so many times. Last one, number 4, read it with me. 4 and 1/3 minus 1 and 2/3. Fractions first. 1/3 minus 2/3. Could I do it? I would get a negative number. So I borrow. So 4 is going to become a 3. And then 3/3 plus 1 more third. 4/3 minus 1 and 2/3. Now fractions first, and I can do it. And 3 minus 1 is 2. So go ahead, check your work, and re-watch this video if you need to, as many times as you need, so that you can feel comfortable subtracting mixed numbers, especially on some of these trickier ones that require you to borrow.